right, so what makes Elemental different? There are a lot of different things that we've put into our product and that our product is built around that differentiate us from our competitors. First off, we are a software-based company. We can run in the cloud, we can run on an appliance, we can run in a VM, we can run on bare metal boxes. We consider ourselves a software company, however, we do sell appliances to enable you to physically get something in, like an HDSDI or SDI or IP, ASI, into our boxes. We will provide it in that form factor. Originally, when we first came out with our first software stack, it was doing transcoding. So we were taking file formats from, let's say, an MPEG-2, and we were transcoding them to an MPEG-4. The difference that we made when we came out is we assigned all of those processes over to the GPUs, where you have thousands of tiny processors in a GPU unit. We were doing it like 5 to 10 times real time. So really, really fast. That really got us going as a company. We can do both CPU and GPU processing, so we can take advantage of either architecture that we're deployed in. And we're based on Linux systems, so we're secure and reliable. And we wrote to the HEVC codec ourselves, so we were the first to market. What is adaptive bit rates? Well, when you first log on to an Amazon site, you may sometimes get really kind of cruddy video and it will suddenly become beautiful. That is the function of adaptive bit rate. So there are many different streams or bit rates available within a video, but these players can, on your devices, can adapt, and they're very smart and can figure out in your environment how to best make that video look on that device. So it's really the encoder is responsible for creating all these bit rates and making them time aligned, and then the player is responsible for searching out the best one on that device to play in the allowable bandwidth that your device or your computer or whatever you're watching it on is within. I guess if there's one downside sometimes, it can be that they're all unicast. You can't multicast any of these. But these are all the standards that are being deployed today. All of these formats that you see here are all made for in-home mobile delivery. You're using them every day by going to Netflix or Amazon Prime and watching videos. Any of these videos, they're all using ABR or adaptive bitrate. They're all HTTP formats. So if you take HLS, which is Apple's format, you have smooth streaming, which is Microsoft's format, HDS, which is Flash, and then the most recent one, which is Dash, which is an MPEG standard. So here's how it works. So somewhere off to the left, you've got an origin server that is delivering the devices, and it's smart enough to know what is dialed in. So when you go to a video in Netflix, you select that video, the origin server over here to the left is saying, okay, I recognize that you're an iOS device, I'm gonna send you HLS. So what happens is it delivers this manifest file, and on this manifest file it tells the player those bit rates that are available. So it will start at the lowest and work its way to the highest within the bandwidth. We can chunk our frames into 10-second frames, and this is totally adjustable, and you will want to adjust it depending on the device that you're delivering to. So where we were in '95, we were doing MPEG-2, and when we came out with HEVC, the marketing term that never caught for MPEG-4, we achieved 50% bit rate savings. And we've done that again. We're really close to at 50% of MPEG-4. So what makes it different is it's a lot better at predicting macro blocks, understanding exactly the image makeup. A lot more algorithms involved in this process, so it takes a little bit more machine work to be able to encode it and decode it. Can make some better assumptions over a wider area. Get twice the quality at the same bit rate is really the story here, or same quality as MPEG-4 at half the bit rate. Where we're seeing a lot of this is moving things across satellite or across WAN. What we'll do is we'll take in whatever they want to deliver, we'll put it in real-time transcode it in our Elemental Live product, and we'll move it across the network with a 50% gain in quality, or use half the space. And then on the other side, we can break it back out to MPEG-4 in real time for consumption. Or we could keep it in HEVC if the devices can use HEVC, making it playable by all the different formats. UHDTV, what is the difference? Well, again, it's a marketing term versus a technical term, I guess. Be calling it 4K or UHD, it really just depends. Different manufacturers will pick up the different terms. So what is it and what do we do? So we are doing 3840 by 2160, 16 by 9. You can go up to 120 frames per second in 25 or 50, or 30 and 60. 24p is also supported, and the audio stays the same in the carrier, and you can get an 8, 10, or 12 bit. So it is supported in HEVC as well as 264. MPEG Dash is a container, MPEG Transport Stream, as well as HLS. Elemental Live is our encoder, our live encoder. Elemental Server is our file-to-file transcoder, like I mentioned earlier, really fast at transcoding, faster than real time. Elemental Delta, that is our origin server. We're getting ready to release an Edge server as well. Elemental Cloud, the best cloud service out there on the market for transcoding. Elemental Conductor, which is our management tool, handles failovers, it handles management of all the channels, things of that nature. These can all be deployed in the cloud, in virtual machines, or appliances.